Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the maximum length of repeated subarray problem. Given integer arrays nums1 and nums2, return the maximum length of a subarray that appears in both arrays. So here we've got 1, 2, 3, 2, 1, 3, 2, 1, 4, 7. It's that 3, 2, 1 that is a maximum length subarray. 2, 1, and 1, of course, are also subarrays, as is 2, and as is 3, but they're not long enough, basically. We only need to output 3, we don't actually care what the subarray is. Here, obviously, 0, 0, 0, 0, 0, 0, 0, 0, 0, they're both full length, so the full length is 5. My immediate instinct is I don't know a good way to solve this, but I know a way to solve this, which immediately makes it a good way to solve this, I guess. If you have a solution, it's a good solution. So I'm also noticing the bounds are fairly small, and that's telling me that there probably isn't a super amazing way to do this. So I think at the end of the day, we're basically just going to have to do a search. So 1, does that match a 3? No. 2, does that match a 3? No. In fact, sorry, no. 1, does that match a 3? No. 1, does that match a 2? No. 1, does that match a 1? Yes. Length 1. 2, does that match a 4? No. 1, does that match a 4? No. 1, does that match a 7? No. Now, obviously, we could speed some of that up, borrow some of the Nuth-Morris-Pratt sort of optimizations, but I think to begin with, this is going to be fine. So longest is equal to 0, oh, 1. Current equals 0. I equals 0, j equals 0. Actually, how do I want to do this? No, let's just start with j equals 0. For I in range len nums 1, for, actually hang on, j in range len nums 2, hang on, offset equals 0. So we're looking at I0, J0. If nums I plus offset is nums2j, that's nums1, offset plus equals 1. I don't even know if I need current anyway. Else if they don't match, offset equals 0. If offset is greater than longest equals offset. So the thinking, I don't need a semicolon. So 1, offset is set to 0, 3, 1 equals 3, no, offset still 0, offset gets set to 0, 1, 2, no, 1, 1, yes, offset gets incremented to 1, 2, 4, no, 1 is not greater than longest, offset gets reset to 0. But here's the problem. I then start looking at 1, 7. So I need to do this somewhat manually. When do I need to do this? If offset equals 0, j plus equals 1. We didn't match at all. So 1, 3, increment j. 1, 2, increment j. 1, 1, increment offset, increment j. 2, 4. Offset gets reset to 0. 1, 4. Increment j. 1, 7. Too far. Loop around. 2. Okay, I think that is the correct procedure. Let's see what happens when we finally get to 3, 3. 3, 3. Yes. 3, 2. Yes. Sorry, 2, 2. Yes. 1, 1. Yes. If I plus offset is greater than or equal to the length of nums1, if offset is greater than longest equals offset, break, I guess. Break out of the loop. We've made it all the way to the end. There's nothing more we can do. In fact, if we make it all the way to the end, we can just straight up return longest, can't we? Because this is as early as we could start. If we've already found something longer, well, that must have been the longest thing. If this is the longest thing, you're never going to find anything longer because we're always going to start at least one mark later. I think that's it. Typo check. Looks good. Let's use both test cases. No. It found 4. They plus 1. Oops. Offset plus 1. No, hang on. Something's gone wrong here. Zeros match. Offset gets set to 1. Zeros match. Offset gets set to 2. Offsets match. Offsets match. Offsets match. What? Why is it telling me 4? 0, 1, 2, offset 1, offset 2, goes off the end, offset 1, offset 2, offset 3, goes off the end. Huh. Offset does not equal 0. Offset plus equals 1 if offset is greater than longest. Longest equals offset. Is that the case I'm missing? We've run out of J's. Now I've got a bloody 6 on it. But that is the case that I was missing. So here, I never got around to stepping off the edge because we'd stepped off the edge in J's first, which obviously isn't going to work. This condition will break, so we were getting down to the end here, leaving off and basically never fixing offset. We'd have to do other things. Effectively, we'd start here and find this chunk. Strange edge case. I'm just thinking there might have been an easier way to do this with a matrix. What you could do is you could do the matrix of equality, where these two arrays are equal, and then you're just looking for the longest diagonal of trues. That could have been a cool way to do it. Let's see how this goes. We might be switching tactic. Ooh, seems pretty slow. Oh, my longest should start at 0. Oh, that was definitely not the way to do it. Oops. Oh, frog in my throat. Excuse me. They expected 9. Oh, they expected that one. How was I meant to get that one? 1, 2, 3, 4, 5, 6, 7. So why didn't that? They match, they match, they don't. Okay. So it gets all the way through with those offsets. You know what? I want to try this other way with the matrix. I think I can hack this till it works, but the matrix way sounds fun. Then to do the longest diagonal, what I want to do, I know they're the same length? No, I don't know that they're the same length. That's all right. The diagonals of a matrix, of a rectangular matrix, are obviously the one that starts at 0, 0 and goes down the diagonal until the minimum of width or height, and then sort of spans out like that. So the start is going to be for I in range len nums1 pass for j in range len nums2 pass. So I didn't need to do that. Return longest. So let's assume we have this diagonal this matrix of trues and falses. So if we're starting at first we start at 0. In fact, I want to make these both. Yeah, no, I want to make that j. J equals 0. Excuse the noisy motorbikes in the background. Is it always j equals 0? So if I is going along, let's say nums1 is along the top. So I is going along the column. Yeah, we always want j to start at the top. And then while now which one is it? We want to keep going until I is less, in fact no, hang on, let's call these x, y are 0, 0, while x is less than len nums1, oops, I, 0, and y is less than len nums2, whoops, that's a len nums1, count equals 0. If equal x y, I'll let the other way around, y x count plus equals 1. If longest is less than count, count at longest equals count, else count equals 0. And just keep working our way down those diagonals. So that would get us 0, 0, 1, 1, 2, 2, oops, x, y equals x plus 1, y plus 1. And then I want to do the same down here, except I want x to always be 0 and y to start at j. The rest is identical. I believe. So now let's do this matrix. Def equality matrix self nums1 nums2. So what we want to do is matrix is equal to the false times len nums1 for underscore in range len nums2. Then it's for x in range len nums1 for y in range len nums2. Mat y x is equal to nums1, x is equal to nums2 y. Return matrix. Does that work? That seems to work. We got it right first time this time. Let's throw in these extra test cases. I should also do my they're not equal anyway test case, but that seems to work this time. I like this solution better. 1, 2, 3, 4, 5, 6, 7. Let's see what happens with unequal. That's a numbers 1. That's why we do these tests. Perfect. My mic has a drooping problem today. I don't know if you can hear that or not. Keeps wanting to go down onto my desk. It's still pretty slow. Time limit exceeded. Yeah, I was worried that would happen. So, what's the complexity of this? This thing's quadratic. This thing is also quadratic. So all in all, it's quadratic because they're not nested in any way. We're just doing 3 quadratic loops. Can I avoid searching some of the matrix in some way? Well, I can stop early if I ever get a length equal to the list, one of the lists. They can never be anything longer. Is there any other reason I could stop? Well, there is one reason I could stop. I have a meeting in half an hour. I need to get ready before that meeting starts. How big are you? Yeah, not huge, but when done quadratically, you're quite big. Am I accidentally searching too much of the matrix? So this one is going to see 0, 0, 1, 1, 2, 2, 3, 3, and then it's going to see 1, 0, 2, 1. Whereas this one is going to see 0, 1. No, so this is always going to be a case where they're equal or I is greater. And this is always going to be the case where the second thing is greater, y is greater. So x is greater, y is greater. So they're searching different parts of the matrix. But if I know these 3, 2, 1, and these 3, 2, 1, I don't need to search all the way out to the corners of the matrix. because of where I'm starting from, I'm probably going to find the longest one earlier rather than later. The trick is, can I exploit that? Can't immediately think of a way to do it, so I'm going to do something perhaps a little bit cheeky. Oops. Oh, for goodness sake, what is the shortcut for commenting out code on the... There we go. Different on every damn editor. Which is shorter? If len nums2 is less than len nums1, nums1, nums2 is nums2, nums1. For I'm reluctant to do what I'm about to do. So I'm thinking string search in Python's probably already optimized to heck. But I won't know the length, will I? Oh, yes, I will. No. So I can use that probably to my advantage. Whether it's fast enough, I don't know. But I'm just sort of thinking, well, how do I find the maximum one? Well, I'm going to start searching for all 5. Then I'm going to start searching for 4 by cutting 1 off from each end. Then I can start searching for 3 things by cutting 1 or 2 off from each end. Those are going to be my 3 searches. And then I want to search for 2 things, so that's those. No, that'll bring them false positives. Because if I have 3, 2, 100, I'd call that a success. No, that's not what I want then. I feel like we're onto something here. I just don't want to do a proper search algorithm because they're so fiddly and I can't remember how it works. missing here? Maybe this equality matrix could be made differently. For x in range len nums1, for y in range len nums2. Let me just grab this matrix. The difference is I don't want it to all be falses, I want it to be zeros. And what I want to say is what order do I want to traverse this matrix in? Well, let's just do it in the naive order. If nums1 x is equal to nums2 y, mat y x is equal to, it gets set to mat y minus 1 plus 1. In fact, we could be extending this in either direction, couldn't we? Mat y x minus 1 so what I want to do is start both of these at 1 and make sure that when I initialize the matrix it has 1s in the first column, so for x in range len nums 1, y equals 0. If nums 1 x equals nums 2 y, mat y x is equal to 1. No, even that's not quite right, is it? No, that is right, that is right. And then I want to do the same thing again, but now for y. Whoops, oh my god, nah. Shortcut keys are all wrong in this flaming editor. And then I just want the maximum value that's inside that array. Of course, it's wildly wrong. Gods above. Okay. Just show me what the matrix looks like at every step, please. So it initially starts, we have that matching with that, and that matching with that. Well, that makes sense. We then find 2 matches with a 2. Makes sense to me. We never find three matching with 3. Do we? What's that one? That's a 2 as well. So this is the row for a 1. This is the row for a 2. This is the row for the 3. Oh, so we do find the 3s match. But then when I'm looking at X, Y, oh, should this be Y minus 1, X minus 1? That. That's better. It seems a fair bit faster, but difficult to tell on the tiny test cases, isn't it? Let's get rid of all of this other crap that we don't need anymore. That was a waste of time. The matrix idea led me in the right direction, I think. I'm running out of time. This is a bit more like a knapsack problem. There we go. So, still quadratic, but 1 passed, not 3. So big O stayed the same, but the constant factors got a bit nicer. Excellent. Okay. That will do us for today. That was a slightly harder one. Got my brain working. Thank you very much for watching, and I will see you next time. Bye.